Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. Today we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi class, lesson number 4. I'll warn you before we jump in, I'm going to be going over some concepts today as well as the code, so this video might get a little long, but I do hope it's worth it. Let's jump in. So the first thing we're going to look at is actually last week's program. We're going to be looking at lesson number 3 and our grade calculator. And I'm going to run this program again. And in the same manner, I'm going to do 3 grades. We do an 88, 97, 100. Oops, I hit the backslash key above the enter key. Does that ever happen to you? Because you know what happens if you do that? It crashes the program. What about, I wonder, what kind of values can I put in here? Can I try a 0? Divide by 0. I didn't check for a divide by 0. What if I try something invalid, like a -5? Same divide by 0. So you see what's happening here is we are taking input from the user and we're not validating it. Let's take a quick peek at the code and see what's going on. What we're doing for simplicity is taking my num grades, forcing it into an integer. I should say we're taking an input, forcing it into an integer, and then storing it in my num grades. Well, there's nothing here to verify that what is input from the keyboard will actually fit into an integer. And there's nothing to verify that that integer, when we get down to this for loop, is actually greater than 0. Because no matter what we put in here, it has to be an integer greater than 0, otherwise the program will crash. So we need a way to validate the input. And that's one thing that we're going to look at today, and that's why I wanted to demonstrate to you what's going on. So let's take a look. I'm going to clear this out. Not clear. See, that's why we validate user input. We don't type well sometimes, especially when we're on camera. So now I'm going to run my lesson 4 program. Before I do, I'm going to switch views because I want to grab a view of the redabbler to make sure that we know what's going to happen here with the LED. So I'm going to run my program. And first of all, we say how many blinks. So I'm going to say 3 blinks. And I did a little throwback to Arduino. I decided to prompt for the number of milliseconds of delay. If you think of the simple blink program in Arduino, it's pin high, delay, usually 1000, pin low, delay 1000, loop, loop, loop forever. In this case, we can actually specify the delay as well. I'm going to leave it as 1000 just for demonstration purposes. And now let's watch the redabbler. 2, 3, perfect. We got the 3 blinks. You might have noticed there was a slight delay between the time I hit enter and the time we got the first blink. That is because my screen is up here directly in front of me, but my redabbler is down there. And so the time it takes me to turn my head and look down, sometimes I miss the first blink. When I was first writing and debugging the program, I was wondering why I was off by 1. As it turned out, I just wasn't turning my head fast enough. So I put a little delay in there so that it won't start blinking until I've fully turned my head and given the board my full attention. Of course, here on the screen, I can just look up. It's a little bit easier. Now you'll notice after we did the 3 blinks, delay 1000, we're back to asking how many blinks. So that was a requirement of this week's class, is to enter how many blinks, blink the LED that many times, and then return and ask again. So now let's do, this time we're going to do 5 blinks, but instead of 1000, I'm going to do 500 milliseconds. I'm going to go blink a little faster. And here we go, 1, 2, 3, 4, 5. There we go. Now, as you may recall from class, we need a way to gracefully exit the program so that we can clear the GPIO pins. Otherwise, when we launch the program next time, we'll get an error. So I've put a little break in here. I can type the letter Q and exit out, and we're okay. Now, I was talking about error handling, so let's try some invalid data. How many blinks? R. Oh, that was invalid. Let's try again. How about backslash? How about 0? How about -30? And you see, it just keeps prompting us over and over and over again. Every time we enter an invalid value, it rejects the value and asks again. So now we'll go ahead and do 4. And the delay value is, again, 1000 by default. I want to set -5. Oh, that didn't work. What about RT? No, that didn't work either. Backslash? That didn't work either. What about 0? Nope, it's not going to take invalid data because I'm doing checking every single time it goes through. It validates to make sure that that's a real number. So now I'm going to set it to 500 again. So we did 4 blinks. We'll do 500 milliseconds. 1, 2, 3, 4. And now let's go through again. And we notice that the default changed. It remembered the last valid value we used. So my last value was 500 milliseconds, and it says, okay, this time from the loop, we're going to assume 500 milliseconds unless you tell us otherwise. So let's do 1500. 1, 2, 3, 4. There we go. And now again, I'm going to queue to quit. And now let's take a closer look at the code and let's see what's going on here to make all of this work the way I want it to. So I'm going to come over here into my code window. And I am not at the top of the code. Let's go up to the top. So the first thing I want to address is the fact that since this is our very first GPIO program, we need to do a couple of things to make sure GPIO is going to work in Python. The first thing is I put up here in the comments the pip command. So you'll notice again that I'm in my virtual environment, TopTechBoy Raspberry Pi Python environment. So within that environment, I'm going to do a pip install rpi.gpio. That gives us the GPIO library, and we can interface with the GPI pwns. The other thing I ran into is I am not logged into the Raspberry Pi as the Pi user. I'm logged in as a user I created called dev. The Pi user in Raspbian has some special privileges. It's a member of the sudoers group. It has an exemption in the sudoers file to sudo to root without password. And it also is a member of some interesting groups, one of which is a group called GPIO. And until your user is a member of the group GPIO, you will get an error when you try to run this code as a non-root user. So what I had to do is go into Etsy group and add dev to the GPIO group, and then completely log out of my session, log back in, relaunch Visual Studio Code, and then I could run my code against the GPIO pins. Now I have permission to use it. So I import GPIO, set up a few environment variables here. Blink flag, blink num. These are used, well, blink num gets set obviously, but blink flag is a trigger that I use as part of my validation process. And I've chosen to go with the BCM numbering as opposed to the board numbering. In our next video, lesson 5, I'm going to talk about the BCM versus board and why I've decided to do it the way I've decided to do it, but I'm going to leave that till the next video. And then of course I'm setting up my GPIO pin as an output. Now the first thing we do is we determine the number of blinks. So I've got a while true, the whole program is run in a while loop because we want to input the number of blinks, get the value of the delay, blink the LED, and then come back and ask again. So the whole program is run in a while loop. This LED blink num is set to 0 because we're going to blink it 0 times. And every time through the loop, we're going to ask how many blinks. First thing I do is I check to see, is the input value equal to Q? And what I'm doing is I'm taking this LED blink num, which actually I got to back up a little bit. I'm sorry, I skipped a step. So my input is how many blinks Q to quit. And instead of an int, I'm taking this as a string. You saw in lesson 3, when I take this as an int, if I throw a alphanumeric character in there, an alpha character I should say, it's going to crash the program. It can't convert it to int. So I'm going to take LED blink number before I do anything with it, and I'm going to kick it in as a string. So that way it's going to blindly accept whatever the user inputs. Now we're going to go through and do some testing. If the blink number dot upper mean we're going to take whatever was entered and move it to all uppercase is equal to uppercase Q, GPI will clean up and exit. So this is our way out. I can enter an uppercase Q or a lowercase q, and it's going to do the cleanup routine and exit the program. Then we're going to use a tool, I should say a function called try, and we're going to, in a test container, we're going to take a look at this value and see, is this a valid integer or not? So I'm going to try converting this to an integer, taking an int of LED blink num, storing it into LED blink num. If it's successful, it moves along. If it's not successful, we run this except function, and we say, hey, that was invalid, and I'm going to take whatever was in that string and write it back to 0, because our while loop is saying while 0. So by writing it to 0 here, I'm forcing it back through the loop. I'm also checking to see if it is greater than 0. So if my blink number is less than 1, because we've already converted it to an integer, it can't be a float value. If it's less than 1, we do the same thing. That was invalid, set the blink num to 0, and loop through. Finally, we have a valid value, so now we come down here, and we're going to use, instead of the blink num, we're going to use blink flag. And the reason we're using blink flag is because this isn't going to get set as part of the user input this time. We're going to have to maintain this kind of manually to our own devices. So while it's 0, so we set it to 0, and then while 0, we're going to go through and ask the user for the delay. First thing I'm going to do is I'm going to take the existing blink delay and I'm going to save it as default, because the default is how we're going to present it to the user. Enter the delay in milliseconds. The default is whatever it was last time, or if you remember way up top, I have default set to 1000. I check for a null string, which is the enter key, and if it's the enter key, I just say, okay, well then we're going to keep whatever that delay is, we're going to keep it as blink. Whatever that default delay is, we're going to keep it as the blink delay. Now we're going to evaluate it, very similar to how we did it above. We're going to try putting it into an integer, and if successful, we're going to set the blink flag to 1. That way when we come through the loop again, it's going to say, oh, nope, it's not while 0, it's now 1. Move on to the rest of the program. And I'm going to check to see, again, is it an integer less than 1? Is it 0 or smaller? Invalid entry. We're going to take blink delay, set it back to the default, which we saved off earlier, set the flag to 0, go back through the loop. And then we again have our except function, which is something other than an integer. We don't know if that was a null character or an extra ASCII character. We don't know what that was. Invalid. And we do exactly the same thing. We wipe out whatever's in LED blink delay with the default, set the flag to 0, we go back through the loop and we try again. Finally, we get to the point where we say, hey, all is good. We have an integer value for our number of times through. We have an integer value for our delay. Here's that delay I was talking about. There's a 1 second delay between the time the program starts and the LED starts blinking. That's again so I can turn my head and look at the board. That's the only reason that's there. And then we're just going to do a simple for loop for counter in range 0 to LED blink num, because we don't care what this value is, we just care that the number of instances is correct. So if blink num is 3, it's 0, 1, 2. Oh, that's fine, just still get 3. Now I'm going to set the output to true, do a delay, and what I'm doing here is I'm taking that blink delay, and because it's in milliseconds, dividing by 1000. So if I put in 500 milliseconds, it's going to do 500 divided by 1000. That's 0.5. That's a perfectly valid value for time.sleep. Then I'm going to set it to false, time.sleep for the same delay. And once it's done, I'm going to set LED blink num to 0 because, if you remember, all the way at the top of our loop, while LED blink num equals 0. So it sends us right back through the loop, and we do it all over again. I really hope that made sense to you guys, because this is kind of important, especially to me, that we validate all the user input. I don't like having a program crash in an uncontrolled manner. I'm really looking forward to next week's lesson, lesson 5, and I will see you there. This is Brian from Simply Brian Enterprises. Thank you for watching.